Today I'll talk about Venturimeter. So first, what is Venturimeter? A Venturimeter is an instrument used to measure the discharge, that is volumetric flow rate or volume flow rate through a pipe. It is based on principle of Bernoulli's equation. Now what is the application? The Venturimeter measures the flow rate by utilizing the pressure difference created by a change in cross-sectional area within the flow. I'll discuss. Now what is the principle behind Venturimeter? A Venturimeter operates based on Bernoulli's principle, which states that for an incompressible non-viscous fluid, the sum of pressure energy, kinetic energy and potential energy per unit volume remain constant along a streamline. Now coming to the Venturimeter. So Venturimeter has three parts. One is called converging section, throat and diverging section. So this is pipe in same as pipe diameter, and this is converging section. This portion is called throat and then diverging section. Now converging section. So that converging section acts as a nozzle, increasing the fluid velocity and decreasing the pressure. So here that velocity will increase and decrease the pressure. And throat section with the smallest diameter, where the fluid velocity is highest and pressure is lowest. And diverging section gradually increase the fluid pressure back towards its original value. So here you remember, this is converging section, throat and diverging section. Now horizontal Venturimeter. So first here that I am taking 2 points, so point 1 and point 2. So here D1 is the diameter of the pipe at section 1, D2 is the diameter of the throat at section 2, throat diameter, P1 the pressure at point 1, P2 pressure at point 2, V1 velocity at point 1 and V2 is velocity at point 2, A1 is the cross sectional area at the section 1 and A2 is the cross sectional area the section 2 or point 2, H is the height difference of the manometer's liquid, and rho is the density of the fluid, or you can rho L is the density of the fluid, and G is the acceleration due to gravity. Now I am applying Bernoulli's equation. So point 1 and point 2 for section 1 and section 2. So we know that Bernoulli's equation neglecting head loss, so P1 by rho G means here I am considering there is no frictional losses. So here P1 by rho G plus V1 square by 2G plus Z1 is equal to P2 by rho G plus V2 square by 2G plus Z2. Now this is a horizontal Venturimeter, so Z1 is equal to Z2. So here that equation become P1 by rho G plus V1 square by 2G is equal to P2 by rho G plus V2 square by 2G. Now from here we can easily calculate. First we are taking that P1 by rho G minus P2 by rho G, we are considering H. Now if we considering P1 by rho G minus P2 by rho G, difference is H, pressure difference is H, so we can write V2 square minus V1 square is equal to 2GH from this equation. Means first we are considering this, okay, and then we will get this V2 square minus V1 square is equal to 2GH. Now using continuity equation, so if I use continuity equation section 1 and section 2, we can write Q is equal to A1 V1 is equal to A2 V2. So V1 is nothing but Q by A1, V2 is also nothing but Q by A2. So now here we can easily calculate, we put V1 and V2 in that equation here, V2 square minus V1 square 2GH. So we can plug that V1 and V2. So Q by A2 square minus Q by A1 square is equal to 2GH. Now from here, so we can write Q2 square by A2 square, Q2 minus Q2 square by A1 square is equal to 2GH. So Q2 square is common, so we'll get 1 by A2 square minus 1 by A1 square. Now if I do the calculation, so A1 square minus A2 square by A1 square by A2 square is equal to 2GH. Finally Q square is equal to 2GH A1 square by A2 square divided by A1 square minus A2 square. From here we can easily calculate total discharge, or sorry, theoretical discharge. Theoretical discharge Q is equal to square root of 2GH A1 square A2 square by A1 square minus A2 square. Okay, now what will be, this is theoretical discharge. Now what will be the actual discharge, because we are neglecting that head losses, but a real scenario we have to consider that head losses. So the actual discharge is less than the theoretical discharge due to energy losses. So actual discharge is given by Q actual. So we are multiplying with one coefficient, that is the coefficient of discharge, root over of this term. Now A1 A2 will be coming out from the square root, so CD into A1 A2 root over of 2GH A1 square minus A2 square. Now the what is that CD? CD actually the coefficient of discharge, so that is the ratio of actual discharge to the theoretical discharge, so that is CD. Now what will be the typical value of CD? So if that CD is 1, so Q actual is equal to Q theoretical, but that is not the case. For well designed Venturimeter, CD range is 0.97 to 0.99. remember that, it is very important. An average value of CD is 0.97 is commonly used. So that CD generally we can take CD is equal to 0.97 and we can design the Venturimeter. Now here is some correction of that H. So as you know, here in the Venturimeter is connected with U-tube manometer. Now we have to correct the H because condition here, if the differential U-tube manometer contains a liquid which is heavier than the liquid flowing through the pipe. Now if you consider that water is flowing through a pipe and manometric liquid is a mercury, so we must correct that H. So here H will be X into rho manometer divided by rho pipe minus 1 is equal that H is equal to X into this rho manometer by rho pipe minus 1, where rho manometer greater than rho pipe. Now actual cases, so pressure difference we took that H is equal to P1 by rho g minus P2 by rho g. So here density of heavier liquid used U-tube manometer, that is rho manometer, rho pipe density of the liquid flowing through the pipe, and X is the difference of heavier liquid column in the U-tube manometer. Now from here, so if I consider that water flow through pipe and mercury is used to manometer, then the equation become H is equal to X rho Hg minus rho H2O minus 1. So now if rho H is 13,600 and rho H2 is 1000 kg meter cube, so H will be, that is 12.6 into X. So here the head difference H is related to the height difference X in the manometer by the factor 12.6. Now remember this should be, so this should be actually X. Now we can find H. So H we can get that 12.6 into X. So that's it about Venturimeter. Thank you.